Hello, Honors Chemistry, and welcome to Chapter 7, Section 7.1, where we introduce some common types of reactions. Like as is often the case, right, really we are just talking about a tiny subset of reactions that you might study, say, I don't know, should you take some more advanced chemistry in college, right? But we have to start somewhere, right? So we've picked out a few common types of reactions, right? So here with this beautiful volcano, we can see a gas evolution reaction, right? Where if we take some vinegar, which is acetic acid, life things we should know, baking soda, which is sodium bicarbonate, another life thing we should know, and if we mix those two things together, we get the production of carbon dioxide gas, right? And some water, and some, well, salt, which we will clarify later. But salt just means what? Right, an ionic compound, right? As in whatever's left becomes our ionic compound, right? We also have precipitation reactions, where precipitation reactions, oh, by the way, gas evolution often falls under the realm of acid-base, which we'll talk more about later. And then we have soap in water, which your book talks about as an example of a precipitation reaction, right? We will see that this one is clear, right? And we've talked about when we take observations, right? It's important to note that clear just means that light will pass through, right? Uninhibited, right? This one, though, is cloudy. And if it is cloudy, right, that means that there is some solid in that liquid. Yes, that's why it's cloudy, right? That's why the way light passes through is affected, right? Even if we can't necessarily discern that there is a distinct solid present, right? But the fact that it's cloudy tells us there is very minute, very tiny particles of solid distributed throughout that liquid, right? Which makes it cloudy. And that is the principle behind hard water, right? And discoloration on your clothes over the long term. Thankfully, Memphis actually has pretty good water, right? So that's not a huge problem here. And then it gives you combustion, right, as an example of redox reactions. Again, we'll talk more about these later, but this is just an introduction to the types, right? Okay, so evidence of chemical reactions. How are you going to know when you look at a process if it's a chemical process or a physical process? And if we go back to Chapter 3, I think it is, right? Remember that a physical change means all we're doing is changing the distance between the molecules, right? So if we think about going from a solid to a liquid, we're putting a little bit of space between those molecules or atoms. If we go from a liquid to a gas, we're putting more space between the atoms or molecules, but the atoms and molecules remain unchanged. Whereas in a chemical process, the key difference, right, is that the arrangement of the atoms is different, right? So outside of a chemical analysis, right, what's some evidence of chemical changes, right? And this is what we're going to look for, right? Color change is often a cue that the chemicals have changed, right? Because, you know, if something was blue and now it's pink, right, odds are that whatever it was has rearranged to create a new compound, right? Here, this one is key, right? So the formation of a solid in a previously clear or unclouded solution, which is also known as precipitation, right? So this is known as precipitation, and this solid is known as your precipitate, okay? Now, note that here, one might be tempted to call this a color change, but that would not be the appropriate wording, right? Because the clear solution, right, led to a white solid, right? And so this would be most appropriately a precipitation reaction. Now, if that solid were some other color, right, then yes, we could also tie in a color change. Formation of a gas, right, upon the mixing of two substances, emission of light, or emission or absorption of heat, right? So do be mindful that the absorption of heat is also something to consider, right? And the emission of heat, right, means that the surroundings will get warmer. Yes, does that make sense? Emission of heat, right, means that the surroundings gets warmer. Right, so if we think about combustion, right, so if you think about standing around a charcoal grill or standing around a propane grill, right, we can feel, right, we as the surroundings, right, can feel that heat being emitted and we get warmer, right? If a process absorbs heat, what that means, right, is the flip of that, right, because that makes sense, right? The surroundings get cooler, right, or less warm. Yes, does that make sense, right? Tuck that away. Okay, some points of reference, right? So here, obviously, we have evidence of bubbles, right? Which means gas formation, right? But do be mindful that in this instance, the formation of that gas is Right, a physical change because we are adding heat, right? And here is where we have to be observant, right? If we're adding heat and then we get bubbles, we should understand, physical change, not a chemical change. Let's use our analytical power, right? Here, this is a gray area, right? So for those of you that have ever had the pleasure of using an instant cold pack, right? What this really is this is often urea and water, right? And if you think about how they work, you squeeze it, which means you're popping the little water bag inside, right? And mixing this stuff, and then it gets cold, right? And what that really means is we're just dissolving something, urea, sometimes it's an ammonium compound, right, in water. And the dissolving of something in water, especially the dissolving of an ionic compound in water, tends to be a gray area, right? Because the solution has different properties than just the salt or just the water. But we can also separate them using physical changes, right? Which, going back again to chapter 3, is one of the hallmarks of a physical process, right? So the dissolving of something in water, we would call that a gray area, specifically the dissolving of ionic compounds. Okay, and then thinking about this concept checked here, chemical versus physical changes. So again, if we analyze these to decide which is which, right, we'll see here, right, that we have molecules that are all tightly packed, right? So these molecules are all tightly packed next to one another. Here we'll see, oh look, it's the same molecules, less tightly packed, right? Physical change, yes? Whereas if we look here, right, we have what are clearly water molecules, and we have not water molecules, right? Which means that this is a chemical change, right? Here we have some of these, right? And then we'll see here, oh, these are not those, which means this is a chemical change, yes? Thank you for listening. Be good, and I will see you soon. Bye.